Right, let's start GCSE physics then. So I'm sure you can see we're going to be looking at the atom this week, and we're going to very basically just be looking at the structure of the atom, how we write that whenever we would be writing about the atom or the nucleus in equations, and just all the facts that we need to know about the atom itself. So the first thing that we need to know is about this old model of the atom that scientists used to think was the case before there were experiments to prove what we now know about the atom. So the one that we need to know about is called the plum pudding model. Now, one thing I should have said there before we got started was that I'm going to be writing notes here, as you can see, and I need you to be writing the exact same notes down. Okay, so whatever I'm writing down on my page here, that is what you are writing down on your page. So if you haven't already got a bit of paper and something to write with, pause the video and go and get that now. Okay, right, so the plum pudding model was the model that it was actually someone called Thomson that named it. So this was what he thought the atom was like, and it was basically, he described the atom as like a big blob of positive stuff with little negative bits embedded in it. Okay, so you need to be able to sketch the diagram of it, label the diagram, and give a description of it. So this would be the positive blob of matter, and that's the pudding bit of the plum pudding. Now, plum pudding is not something I'm familiar with, but another way of describing it is like a currant bun or something, so like a wee bun that has all the wee currants in amongst it. And then these little bits here are the negative electrons. And do you notice the detail that I would be putting in whenever I'm labeling? I'm not just labeling it as electrons, I'm saying what the charge is while I'm doing that. And they are the plums of the plum pudding. Okay, so we need to be able to draw that, to label it if the diagram is given to us, or just to describe it. So let's write our description down here. So it is negative electrons embedded in a positive blob of matter. Okay, now the next thing that we need to know about is what the current model of the atom, and it's either called the nuclear model or it can be called Rutherford's model because he was the guy that came up with it. So the nuclear model, we need to know about it. Same idea. We need to know that it was Rutherford, and we need to be able to describe it as well as draw a sketch of it or label a sketch of it if we were given it. So same as we did last time, let's go with the sketch first of all. So this is the model of the atom that you will be familiar with already from chemistry, really. Okay, so we've got the nucleus in the center, and inside the nucleus we've got protons and neutrons. So the protons are positively charged and the neutrons have got no charge, so I'll label these in just a second. Now, really far away, orbiting around the outside, we've got electrons. Oh, I should have done another one. There we go. Okay, and they are negative. So let's get labeling. So electron, and it's negative. We've got proton, and that's positive. We have our neutrons, which are neutral, no charge. and then we would always label the nucleus itself. And because the nucleus has got things in it which are positive and things in it which have no charge, overall it has a positive charge. People quite often will mistakenly say it has no charge, but it's positive because it has the protons inside there. Now, this diagram that I've drawn here is hideously out of scale, okay? So we just make sure that we're aware of that this distance here is really, really, really big. One of the analogies that goes with it is that if the electrons were like the size of the electron orbit here was the size of like a football stadium, then the nucleus would be the equivalent of having like a wee marble right in the center of it. So that gives you a little bit of an idea about the scale that we're talking about here. So we need to be able to label it. We need to know where all the bits are in the atom and all the different charges on them. So let's get our description for that written down here. Right, so our description of the nuclear model would be that we have positive protons and neutral neutrons, and they're in the nucleus, and then there's negative electrons which orbit the nucleus. So get that written down and make sure you know it. Okay, so the next little thing that we need to make sure we know are all these properties of all the different parts of the atom. Okay, so the proton, neutron and the electron, we need to know how to describe their charge and their mass. Now, it's not the exact numbers that we use whenever we're doing this. We use numbers sort of comparing them to each other. So we would talk about their relative charge and their relative mass, and that just means how their charge or their mass compares to the other things, right? So it's not like a mass in kilograms that we need to state or a charge in coulombs. We don't need to give that level of detail yet. Okay, so for the proton, because it's positive, it has a charge of +1. The neutron is neutral, so it has 0 charge, and the electron is negative, so it has a charge of -1. The mass, again, remember this is just relative to each other, so really comparing them to each other. The proton and the neutron are relatively big and about the same as each other. So we say they have a mass of 1, right? So 1 and 1, which means they're the same as each other. The electron is way, way, way smaller in terms of mass. So it, compared to the number 1, has a mass of 1/1840, right? So remember, this is just comparing to these. Now, this number here, you might see, if you look in textbooks or something, you might see this written as 1/1837 or 1/2000 sometimes is used. And in chemistry, sometimes they use a different number. But there have been years in the past where the exam board have been really fussy about this exact number being used. So let's make sure that we use that. Okay, so make sure we get this table drawn down, that we understand what it is, and that we ask if we don't. Now, you're maybe panicking, thinking, what have I done? Have I chosen the wrong subject? I did not choose chemistry. Why are we doing chemistry? Don't worry, it doesn't go too in-depth chemistry-wise. It's not too bad, I promise. Okay, so the next little thing I have given the title, Structure of the Nucleus and Chemical Symbols. Now, the reason that I've focused on nucleus is because whenever we're talking about radioactivity, which is what eventually this is going to lead on to, it's really everything in the nucleus that we care about rather than the whole atom itself. Okay, now chemical symbols, again, you'll be familiar with those from chemistry. Don't panic. You're not expected to be able to like rhyme off the chemical symbol for all the different elements, and very rarely do we even have to use a periodic table in physics, but there will be enough information in the question for you to pick out all the information that you need. So it's important that we know how these chemical symbols work. So let's look at a carbon nucleus. Okay, so hopefully you will be familiar with seeing things written like that with their chemical symbol there and then these numbers. We need to make sure that we know what these numbers actually mean. Okay, now this bottom number here can either be called the proton number or the atomic number. it tells us the number of protons that's in the nucleus or in the atom. So this is the number of protons, and it can be called the atomic number. Now, it's the number of protons really that determines what element it is, right? This number at the top, again, you'll see different names being used for it. Generally, the most common one that is used is mass number, and it tells you the number of protons plus the number of neutrons which are in the nucleus, okay? So it is the number of protons plus neutrons. It can be called the mass number, or it can be called the nucleon number. Now, nucleon just refers to things that are in the nucleus, so the protons and the neutrons, they're the only things in there. Now, from these two numbers, we are able to tell quite a lot of information about the atom itself, okay? So the first thing that we can tell is that it has 6 protons. We can also tell how many neutrons it has. So I'm sure you can do the maths just as well as I can. If there's 14, that is protons plus neutrons, and there's 6, there's protons. There must be 8 neutrons. Now, if it's a neutral atom, as in neutrally charged, we also know how many electrons there are. There must be the same number of protons as electrons. So there would be 6 electrons in this atom. One thing you need to be very careful of, sometimes questions are really sneaky and they will give you information like this, and then they'll ask you how many protons, how many neutrons, how many electrons are there in the atom, and that is fine. But sometimes they'll ask how many protons, neutrons and electrons are there in the nucleus. Be very careful reading the question. There's no electrons in the nucleus, right? They're orbiting around the outside of it. So just look out for wee sneaky things like that. Now, the last little thing I'm going to be talking to you about here this week is isotopes. Now, if you remember whenever I was talking about the stuff up here, I said it is the atomic number or the number of protons that determines what element it is that we're talking about. And that's because there's like different versions of the same element, right? And they're called isotopes. Probably should have said that. Now, up here I drew this chemical symbol for carbon, but that's not the only version of carbon that exists. Another version of carbon has got 6 protons and 6 neutrons, so this number would be a 12. But the thing that links them is this atomic number here, this number of protons. So all carbon atoms will have 6 protons, but they just might have different numbers of neutrons in them as well. So let's get a description of what an isotope is written down here. Okay, so here we go. Isotopes are elements which have the same atomic number but different mass numbers. So that means they've got different number of neutrons, and a couple of examples listed here. So 2 different versions of carbon. See how they both have got 6 protons. So that's the thing that determines them as being carbon, but different mass numbers. Okay. So let's have a wee recap of everything that we need to know and all the stuff that we need to be able to rhyme off by heart. So we need to know about the plum pudding model of the atom. We need to know that it was Thomson that came up with that. We need to be able to describe it like this. So negative electrons embedded in a positive blob of matter. And we need to be able to sketch a diagram. And you'll see the diagram isn't that detailed, anyone can do it. We also need to know about the nuclear model of the atom. We need to know that that is Rutherford's model so that we can recognise that in questions. We need to know that the protons and the neutrons are all inside the nucleus and the electrons orbit around the outside. We need to know the charges of everything in that as well. So from this little table, we need to know these numbers. These ones, again, easy enough to learn. This one here is the one that we need to make sure that we remember. So we need to know the charge and the mass of all the things that make up the atom. We need to be able to read and understand things like this, know what these numbers represent, and figure out some information from them. So the bottom number here is called the atomic number, and it tells you how many protons are in the nucleus. This top number can be called the mass number or the nucleon number, and it tells you the number of protons plus neutrons. So from these two, we can figure out how many neutrons are in the atom or the nucleus. The last little thing then is about isotopes, and we just need to know that isotopes are like different versions of the same thing. So they are elements which have got the same atomic number, so same number of protons, but they've got different numbers of neutrons. Now, I'm going to be giving you some questions that you need to work through, and I'm also going to give you a quiz to do for the end of the week. So the deadline for all this is going to be for Friday. Now I'm actually going to give you a little bit of help with one of the questions here. I'm going to get you started on how you fill out. It's a table, and I'm just going to get you started on filling it out because it can be a little bit tricky. Okay, so one of the questions has got a table like this, and at the start it can be quite confusing to what on earth is going on, and especially with this because you're probably thinking, oh, she said we didn't need to know the chemical symbols, but you can always figure them out. Okay, so these two are two rows from the table that I'm going to be giving you. They're not the first two. I've just picked out, it's actually the second and the third rows. Okay, so let's fill in this top one here. So from this symbol here, we can tell automatically the number of protons is 6. Okay, we can also figure out the number of neutrons because we know if there's 12 up here, the mass number, if that's 12, then it's the number of protons plus neutrons. So if 6 protons, there must be 6 neutrons as well. Number of electrons, whereas these atoms are neutral, so the number of electrons is going to be the same as the number of protons. So that's also going to be 6. Atomic number, this is going to be the same as the number of protons, 6. Mass number is this number from the top here, so that's 12. Okay, now another row in this table, all it gives you is these two here. So first of all, I would fill in the rest of these numbers here. So the number of electrons is going to be the same as the number of protons, so that's going to be 6. The atomic number is the number of protons, so that's 6. And the mass number is the number of protons plus neutrons, so that's these two added together, so that's going to be 14. Then I can come over to my symbol. So the bottom number, remember, is the atomic number, so that's 6, and the mass number is 14. Now, in terms of what element that actually is, if I look back up at other things in my table, I can see that I already know something which has an atomic number of 6 is carbon. So I know that that's going to be carbon. And you need to do that a few times in the table to figure it out, but there's always enough information there. It's always going to be the same as one of the ones that's already in the table. Okay, so hopefully that helps with that particular question. So work your way through the questions and then do the quiz. And remember, all has to be done for Friday. Okay, bye.